Numeric type conversion. Use the int type for all generic purpose integers, constants, and variables in your code, even if they known to be non-negative. Using a default integer type in everyday situation means that integer constants and variables are immediately interoperable in your code and will match the inferred type of integer literal values. Use other integer type only when they are specifically needed for the task at hand. Use the other integer types only when they're specifically needed for the task at hand. Because of explicitly sized data from an external source, because of explicitly sized data from an explicitly sized data from an external source, or for performance, memory usage, or other necessary optimization. Using explicitly sized types in this situation help to catch any accidental value overflows and implicitly documents the nature of the data being used. Integer conversion. The range of numbers that can be stored in an integer constant or variable is different for each numeric type. Numeric type. An int8 constant or variable can store numbers between -128 to 127, whereas a uint8 constant or variable can store numbers between 0 to 255, of course, because there is no negative numbers. A number that won't fit into a constant or a variable of a sized integer type is reported as an error when your code is compiled. For example, let cannot be negative uint8 equals to -1. Since uint8 cannot store negative numbers, this will report an error. Let too big int8 equals to int8 max plus 1. It cannot store more than larger than its maximum value. So this will also report an error. Because each numeric type can store a different range of values, you must opt in to numeric type conversion on case by cases. Because each numeric type can store a different range of values, you must opt in to numeric type conversions on case-by-case basis. This opt-in approach prevents hidden conversion error. This opt-in approach prevents hidden conversion errors and helps make type conversion intention explicit in your code. To convert one specific number type to another, you initialize a new number of the desired type with the existing value. To convert one specific if anything that you cannot pronounce easily, that means you're not pronouncing it properly, because English is a funny language. English accent is made for easy pronunciation. So
Specific.
specific,
Specific.
specific,
Specific.
specific, specific,
Specific.
specific. To convert one specific number type to another, to convert one specific type to another, you initialize a new number of the desired type with an existing value. you initialize a new number of the desired type with the existing value. In the example below, the constant 2000 is of type uint16, whereas the constant 1 is of type uint8. They can't be added together directly because they are not of the same type. Instead, this example calls uint16 1 to create a new uint16 initialized with a value of 1 and uses this value in place of the original. Because both sides of the additions are now of type uint16, the addition is allowed. The output constant 2001 is inferred to be of the type uint16 because it's sum of uint16. So because both sides of the operator addition are of type uint16, the addition is allowed. The output constant 2001 is inferred to be of type uint16 because it is sum of the two uint16 values. Some type of initial value is the default way to call initializer of a Swift type and pass in an initial value. Some type of initial value is a default way to call the initializer of a Swift type and pass in an initial value. Behind the scenes, uint16 has an initializer that accepts uint values, and so this initializer is used to make a new uint16 from existing uint. You can't pass in any type here. However, it has to be type of which uint16 provides an initializer. Extending existing types to provide initializers that accept new types, including your own type definition, is covered in extensions. I think I didn't get the paragraph here. Some type is default way to call the initializer of Swift type, any type, and pass in an initial value. That's basically calling uint16 and pass the value. Behind the scenes, uint16 has an initializer that accepts uint8 value, and so this initializer is used to make a new uint16 from an existing uint. So uint16 has initializer that accepts uint8 value, and this initializer is used to make a new uint16 from an existing uint8. You can't pass any type here. However, it has to be a type for which uint16 provides an initializer. So uint16 itself cannot be called for anything. You can't pass any type here. Does it mean uint16 has to be used only to pass uint8 into it? I mean, that makes sense. I mean, if you are doing just int, you don't want uint16 to be called with higher number. That means you're cutting the value of it. So if you're passing anything that's smaller than uint16, then you can use that value to extend to a bigger number. But if you pass a bigger number, you can't cut it. That means you're losing the value of that number, which is not desired. Integer and float conversions.